Today we will continue our laws of exponents with the power of a power rule. When powers are raised to another power, you multiply the exponents. When there is a coefficient, you also raise that coefficient to the same power. So in this case, what we mean by multiply, if we have some value, in this case a, raised to a power of m, if this is all inside parentheses showing that it is raised to another power, we will multiply the exponent values. An example would be right here, showing that x to the power of 2 raised to the power of 4 is the same as saying x to the power of 2 multiplying itself a total of 4 times. This following our normal order. But now, since these are all multiplied together, this goes back to our product rule where we would add all the powers together. So in this case, we would add 2, 4, 6, 8 for our exponent, which would be the same as 2 times 4. So in this case, since I am multiplying 4 of my exponents, or 4 of my term, that means I'm going to be multiplying it 4 times for the exponent. A couple examples. Example 1, y to the power of 5, all raised to the power of 2, would be the same as our base y being raised to the power of 5 times 2, which would be 10. Now, when we use parentheses and have an exponent on the outside of the parentheses, there's a different way to distribute it than a coefficient on the outside of parentheses. Oops. Let's make this a little bit smaller, easier to follow. As I stated in an earlier video, even if you do not see the number, there is still a number for every value that we have, an exponent value for what we have. This 3 will multiply each exponent as we go on. So for our coefficient, it will be negative 3 to the power of 3. We will have a to the power of 3, because we are multiplying 1 times 3. And then for our b variable, base value, 4 times 3 gives us 12. Now in simplifying, we will raise negative 3 to the power of 3. Gives us a negative 27, and we still have a to the power of 3, b to the power of 12. Now, what we did for our coefficients is what we would do when we would insert a value for a or b. We would still use that exponent. Moving on to example 3, knowing that there is a 1 for the exponent of 2, this means that we are going to have 2 to the power of 3, which is 8. 2 times 2 is 4, times 2 is 8. A to the power of 3 times 3, which is 9. And then our base b to the power of 2 times 3, which is 6. So even if the exponents are switched around, it does not change what we are doing. We are still multiplying 2, the exponent, with 5, the exponent on the outside of the parentheses. So we have a base of x, and we have an exponent of 10. 2 times 5 gave us the exponent of 10. Yet again, everything inside the parentheses is what's going to be raised to the power of 2. 4 to the power of 2 is 16. 4 times 4 is 16. X to the power of 2 raised to the power of 2 is the same as x to the power of 2 times 2, being 4. And we need to remember that there is a 1 for the b exponent, which gives us b to the power of 1 times 2, which is 2. Now this one is not in order, just to follow what we've been doing in our videos, keeping it with our guidelines, saying that we use alphabetical order. Our proper answer would be 16 b to the power of 2, x to the power of 4. These are the same value, it does not change, but following the guideline, we would want to put it in alphabetical order, just the same way as we always put the coefficient to the beginning. Our last example combines the power of a power rule with the product rule. When we distribute this amongst each of the parts of the term, we get negative 4 to the power of 3, which will give us a negative 64. Our x, with a power of 1, will multiply to the power of 3, which is 3. And our y, the same, power to 1 times 3, gives us 3. Now this is multiplying to another set of parentheses, so we need to use the power of a power rule. Negative 2, let's use parentheses for this, because there is another negative. Negative 2 to the power of 3 is negative 8. And then x to the power of 2 times 3 is x to the power of 6. Now this isn't fully simplified. We can go further using the product rule, product law of exponents. We would multiply negative 64 times 8, which will give us a coefficient of 512. We are multiplying a like base, which goes back to the product rule where we add the exponents. 3 plus 6 give us 9. So in all these examples, we're raising the power to each one, which means we multiply. Now we are multiplying, which means that we add the powers. There's only one y base, so we can just leave it as y to the power of 3. So my final answer for number 6 is 512, x to the power of 9, y to the power of 3.